Hello, sixth graders. Today we are learning about ratios. Make sure you have the note template ready to go for this video. A ratio is a comparison of two quantities by division, and we can write this in a couple different ways, which are shown here. So you could write it as 3 to 4, you could write it with the colon in between, you could write it as a fraction, 3/4. Most commonly for math, we are going to be writing them as fractions, but it's just comparing two quantities. Simplify. So for this first question, it says, what is the ratio of rectangles to shapes? So we are comparing the amount of rectangles to the amount of total shapes that there are. So what I'm going to do is I'm going to count the rectangles. 1, 2, 3, 4, 5, 6. Rectangles was listed first, so that's what I would write first on my ratio. And then it says total shapes. So there's 6 rectangles, 7, 8 total items. You could also write it as a fraction, 6/8. And usually we would simplify. So this would simplify to 3/4. So there's 3 rectangles for every 4 total shapes. Next one, what is the ratio of total shapes to triangles? So now total shapes was listed first. So that would be the first item in our ratio. There's 1, 2, 3, 4 total items. And then triangles, there are 2 triangles. So 4 total shapes to 2 triangles. Write it as a fraction, 4/2, which could then be simplified, 2/1, and we would keep it as an improper fraction like that. Next part, at the store, the ratio of books sold to movies sold was 8 to 2. So this means that for every blank book sold, there were blank movies sold. So in our question here, it says books first, movies first. So that means books is listed first, movies second. So 8 books for every 2 movies, or every 2 movies, there were 8 books sold. So just based on the wording of the question and how the numbers showed up. Key thing here, the order is important. The order has to match the wording of the question. Okay, so kind of going back to what we just were talking about, to set up the ratio, you need to know what numbers are being compared and set it up in fraction form. The first item that's listed is your numerator, the top of the fraction. The second item listed is the denominator, the bottom of the fraction. Simplify, but leave it as an improper fraction if that's how it is. You do not turn it into a mixed number. Jane has a bag that contains 3 bouncy balls, 4 marbles, 7 books, and 1 orange. And then we have a bunch of questions based on this information. So the first one, what is the ratio of books to marbles? So looking at the table here, I see that there are 7 books. So I'm going to write that one first because that was the first one listed. Marbles, there are 4 marbles. Simplify if you can, which this one I can't, but you keep it as an improper fraction right here. Important. If it's greater than 1, you leave it as an improper fraction. Next question, the ratio of marbles to books. So again, now the order flipped. Marbles is listed first. So that means that marbles is going to be the top of the fraction and books is going to be the bottom of the fraction. And then again, you would try to simplify if you could. What is the ratio of bouncy balls to marbles? So again, looking at the table, bouncy balls is listed first. So that's going to be the top of my fraction. Marbles is listed second. So that means marbles would go on the bottom. Try to simplify, otherwise you leave it as 3/4. What is the ratio of bouncy balls to total items? So bouncy balls first, so that would go on the top of our fraction. Total items listed second, so that would go on the bottom. So 3 bouncy balls. Now to find the total, we would have to add everything together. So 3 plus 4 is 7, plus another 7 is 14, plus 1 is 15. So there's 15 total items. I notice that I can simplify this to be 1/5. So what that means is there's 1 bouncy ball for every 5 items in the bag. Now we're going to write the ratios. We've been doing it as fractions, but now we're also going to turn it into a percent, which there's a reminder right over here. If you are using a calculator, divide the numerator by the denominator, round to the nearest hundredth, move the decimal point 2 spots to the right, and add zeros if necessary. Add your percent sign. So we have 5 cups of trail mix and it has 2 cups of raisins. What is the ratio of raisins to trail mix? Write as a fraction in simplest form. So raisins was written first, so that's the one that I'm going to put in my fraction first as the numerator. Trail mix is on the bottom, 2 out of 5. Now to write this as a percent, I am going to use my calculator and I'm going to do 2 divided by 5, which is 4/10. Move my decimal 2 spots to the right, fill in with a 0, 40%. What does this percent mean based on the situation? It means that there is 40% of the trail mix is raisins. Okay, and that's just based on what the question was asking for. So it was asking for raisins to trail mix. All right, next we have equivalent ratios. This is ratios that have the same value. So an example here, last weekend, Miss Kraska drove 250 miles in 4 hours and Miss Little drove 500 miles in 8 hours. Are these ratios equivalent? And if not, who had a higher ratio of driving? So first, I'm gonna write them as fractions. I'm gonna write my number of miles over hours for Miss Kraska and then miles over hours for Miss Little. A couple different ways that we can do this. We could simplify the fractions all the way and see if they equal the same number. We could find common denominators for them, which is what I'm going to do for this one, because I know that if I multiply this side by 2, I will end up with 8 on the bottom. And 250 times 2 is 500. So that means that if Miss Kraska could drive 250 miles in 4 hours, she could go 500 miles in 8 hours. Now, since those equal the same thing, then yes, they are equivalent. Next one, Mr. Hansen's cookie recipe calls for 2 cups flour to 8 cups sugar, while Mr. Schaefer's cookie recipe calls for 8 cups of flour to 14 cups sugar. Are these equivalent? And if not, who had the higher ratio of sugar to flour? So again, I'm going to set them up as cups of flour over cups of sugar, cups of flour over sugar. This one, it wouldn't be so nice to find common denominators, so I'm going to just get them to simplest form and see if they equal the same thing. So this side, I can divide them both by 2. So that means that Mr. Hansen uses 1 cup of flour for every 4 cups of sugar. Mr. Schaefer, if I divide these both by 2, we get 4 over 7. So he uses 4 cups of flour for every 7 cups of sugar. So are these equivalent? No, they're not, because they don't simplify to the same thing. And if we had done the one where we get the same common denominator, we would have found that they also are not the same. And then who had the higher ratio? I'm going to go with Mr. Hansen here, or sorry, Mr. Schaefer. His was over half of the amount, whereas Mr. Hansen had a small amount. He had the smaller fraction, I should say. 1/4 is smaller than 4/7. Okay, here's where I would like you to pause the video, try these on your own, and come to class with these ones done tomorrow. If you're stuck or confused, go back, rewatch parts of the video that you are still confused on. Make sure to have your notes in class tomorrow.